This is problem 81 from chapter 6. In the first part of the question, you're asked to find the wavelength of wave A and wave B. And you're given the diagram that has wave A and wave B. And if you count the number of complete wave cycles in A, you'll find that there are 4.5 waves. And those 4.5 waves fit into a space of 1.6 times 10 to the negative 7th meters. So 1.6 times 10 to the minus 7 divided by the number of waves gives you the number of meters per wave, and that's the wavelength. You'll do the same thing for B, or for wave B. Actually, it's not really part B from the question. But there are 2 complete waves in 1.6 times 10 to the negative 7th meters. And so, quick calculation, you get the wavelength for B to be equal to, I believe, 8 times 10 to the negative 8th meters. The next part of this question has you calculating the frequency of the waves. So assuming these are electromagnetic waves, which is what the problem says, we can use the equation C equals lambda nu. Lambda is wavelength, nu is frequency, and we solve it for nu. We know the speed of electromagnetic radiation is 3 times 10 to the 8th meters per second, and so we rearrange the equation for frequency, and we get 8.3 times 10 to the 15 hertz, or seconds to the minus 1. We do the exact same thing then for wave B, except this time using the wavelength for wave B to come up with the answer. Last part of the problem says, what kind of electromagnetic radiation is it? Well, we're going to look at that diagram like the one I have here, similar to one that's in your book. We know that the frequency is on the order of 10 to the 15th, and so that puts it in the ultraviolet range for both of those. It's almost in the visible range, but probably a safer bet is to say that it's ultraviolet.